in the green column, can you see these scores? Young eyes. So on this green column are the final exam results. So they 94, 96, and there were 52 students in this class, monster class, and they range from, I think, a low of 61 to a high of 99. Okay? So the way to do the standard deviation is to add them all up. Add up all those raw scores and you get a sum of the scores. Right? You just add. And then you divide by 53, and that's how you get the mean. Right? That's how you get the mean score. So the mean score was something like an 81 or 82% on the final. That's after the ones that didn't pass took it a second time. This wasn't on the first try. The average on the first try was around the 79, so it came up a little bit. It turns out that the standard deviation on this final is 9.42. So what does that mean? That means that, and I know you've done this before, but that means that if the mean is 82, and this person got a 94, how far away from the mean were they? They're 12 points away from the mean, okay? And this person was 14 points away from the mean, right? They had a 96. And this person was only, at an 88, was only 6 points away from the mean, right? So the standard deviation from that is to add up those numbers, 12 away, 14 away, and then divide by 53, and you get this standard deviation from the mean on my test. So standard deviations from the mean are always specific to whatever instrument you're using. And so a 9.4 standard deviation from the mean is not going to mean anything to anybody because, well, if you know it was a test, you know that that's kind of normal, that you've got a normal distribution going from probably 60 to 100. Generally on med-surg exams, we like people to, that standard deviation to be a little lower. So we like the scores to be a little more clustered together, a little more close to the top. So we like that standard deviation to be a little lower. Generally in research, we like our standard deviations to be low because this kind of a standard deviation. But what does this have to do with the 1, 2, 3 standard deviation I just told you about? So a translation has to be made from, this is the raw data, the raw variable, the standard deviation on my test, then has to get translated into the 1, 2, 3 standard deviation here, and it's another formula. I think some places call them z-scores. But there's a way of taking any test result, any differences between two groups, any kind of test result, and you get a standard deviation that could be anything. It could be 10, it could be 12, it could be 4. What does that mean to you? Nothing. The only thing that's going to mean anything to you is if you get the kind of standard deviation that looks like this. Because this is constant and has meaning no matter what. Because a standard deviation of 1 means that you're in this group of the data. 34% of the people will have a standard deviation from the mean up to the standard deviation of 1. So when you're reading research, if your standard deviation is something that's not between -3 and 3, you know that the standard deviation they're talking about is like my 9.6 on the final. And you're going to have no idea what that means until it gets translated into something that's between -3 and 3. Okay? So when you're